NASA's Mars rover Perseverance has sent back some of the most incredible footage of the Martian surface. Equipped with advanced cameras and cutting-edge technology, the rover has captured high-definition 4K images that immerse us in the surface of Mars like never before. As it explores the planet's ancient terrain, Perseverance uncovers new insights and offers a breathtaking visual journey into an alien world. This continues the legacy of its predecessor, the Curiosity rover, which also delivered stunning 4K visuals of Mars. Both rovers are pushing the boundaries of space exploration, revealing the mysteries of the red planet with every image and piece of data they send back. The importance of these images and the science behind them extends far beyond their aesthetic value. These visuals are not just photographs, they represent a deeper understanding of Mars, its history, and its potential to support life. To appreciate these accomplishments fully, it's necessary to look at how NASA's Mars exploration efforts began and how they evolved into the technological marvels we see today. Over the years, rovers have played a crucial role in expanding our knowledge of Mars. NASA has sent several groundbreaking rovers to the planet, each one more advanced than the last. This effort spans more than 2 decades, beginning with Spirit and Opportunity, which were launched in 2003. Their missions focused on searching for evidence of past water on Mars, and their discoveries provided significant evidence suggesting that Mars once harbored conditions suitable for life. The Curiosity rover, which landed in 2012, revolutionized our understanding of the planet by exploring the Gale crater. It provided high-resolution images and critical data about Mars' climate, geology, and potential habitability. In 2021, Perseverance arrived on Mars with state-of-the-art technology designed to search for biosignatures and collect samples for future missions to Earth. Through the lenses of these rovers, humanity has gained an unprecedented glimpse into Mars' diverse landscapes, helping scientists visualize its ancient history. The journey of the Curiosity rover began on November 26, 2011, when NASA launched it from Cape Canaveral as part of the Mars Science Laboratory mission. The rover traveled an astounding 560 million kilometers, 350 million miles, across space before landing on August 6, 2012. Its dramatic entry, descent, and landing sequence concluded with a safe touchdown in Gale crater, specifically in a flat region near the base of Mount Sharp, a towering geological feature standing 5.5 kilometers high. From this location, Curiosity began its mission to investigate the planet's climate, geology, and the potential for past microbial life. The site was chosen for its diverse geological features and evidence suggesting that water once flowed there. The mission aimed to answer key questions: could Mars have supported life in the past, and could it support life in the future? To achieve its objectives, Curiosity conducted an extensive analysis of the Martian soil and atmosphere, focusing on detecting key elements necessary for life, such as carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. It also searched for biosignatures or biomolecules that could indicate the presence of biological processes. The rover's tools allowed it to analyze the chemical, isotopic, and mineralogical makeup of rocks and soils, providing insights into the geological processes that shaped Mars' surface. One of its standout instruments, the ChemistryCam, used a laser to vaporize small portions of rocks and analyze the resulting plasma to determine their chemical composition. This technique helped scientists map the history of water and volcanic activity on Mars. The rover also studied the current state of the Martian atmosphere, focusing on the cycling of water and carbon dioxide. These observations were vital for understanding Mars' climate history, including its transformation from a potentially warm and wet planet to the cold, arid world we see today. Curiosity's findings could also inform future efforts to terraform Mars or prepare for human exploration. In addition to these studies, the rover measured radiation levels on the surface, providing data on galactic cosmic rays, solar proton events, and secondary neutrons. These measurements were crucial for understanding the hazards of radiation for future human missions to Mars. In 2013, Curiosity made a groundbreaking discovery when it identified evidence of an ancient streambed, suggesting that liquid water once flowed through Gale crater. The presence of clay minerals, which form in the presence of water, further supported the idea that Mars once had an environment capable of supporting life. Additionally, Curiosity's analysis of the Martian atmosphere revealed intriguing fluctuations in methane levels, providing potential clues about biological or geological processes occurring beneath the surface. The rover's high-resolution imaging systems, including the mast cam, provided some of the most iconic visuals of Mars. These images showcased the red, rocky terrain, weathered landscapes, towering mountains, and deep valleys of the planet. The stunning visuals have reshaped our perception of Mars, offering an unprecedented level of detail. Curiosity's design drew inspiration from earlier rovers like Spirit and Opportunity, but featured several enhancements. The rover is car-sized, weighing nearly 900 kilograms, 2,000 pounds, and standing over 2 meters tall. It is equipped with 10 scientific instruments, including the chemistry cam, the sample analysis at Mars (SAM) laboratory, and the radiation assessment detector (RAD). Powered by a radioisotope thermoelectric generator, Curiosity operates continuously, even during Mars' harsh winters and nights when solar power is unavailable. This system converts heat from the decay of plutonium-238 into electrical power, ensuring that the rover remains operational regardless of environmental conditions. The generator also provides heat to regulate the rover's internal temperature, enabling it to function in the extreme Martian environment. Since its landing, Curiosity has far exceeded expectations. Originally planned as a 2-year mission, its success led to an indefinite extension in December 2012. Now operational for over 12 years, Curiosity continues to send back invaluable data. Despite facing challenges, such as a flash memory issue in February 2013 that required NASA to switch to the rover's backup computer, Curiosity has remained resilient. Its onboard computing systems are designed to withstand space radiation, with redundant systems ensuring reliability in the event of failures. Communication between Curiosity and Earth relies on an X-band transmitter and a UHF electrolyte radio, which relays data via Mars orbiters like the Mars Reconnaissance Orbiter. Although communication with orbiters is limited to about 8 minutes per day due to their orbital patterns, the system enables efficient data transfer, even with the 14-minute delay caused by the distance between Mars and Earth. In 2021, NASA built upon Curiosity's legacy by launching the Perseverance rover as part of the Mars 2020 mission. Perseverance landed in Jezero Crater, an area believed to have once hosted a lake. Equipped with advanced features, including improved wheels, a more sophisticated robotic arm, and MOXIE technology to produce oxygen from the Martian atmosphere, Perseverance has made significant discoveries. Its instruments revealed that rocks in Jezero Crater likely formed in an ancient lake environment, making them ideal for preserving signs of microbial life. The rover also identified igneous rocks, suggesting a more complex geological history than previously thought. Perseverance carried a special passenger, the Ingenuity helicopter. Ingenuity became the first powered aircraft to fly on another planet, completing 72 flights before its retirement in January 2024 due to damage. This achievement demonstrated the potential for aerial exploration on Mars, paving the way for future missions. Perseverance continues its mission, collecting samples for eventual return to Earth and conducting detailed surveys of the Martian surface. Its findings, along with those of Curiosity, contribute to humanity's understanding of Mars and its potential for past life. The scientific innovations developed for these rovers will shape the future of space exploration, bringing us closer to the goal of sending astronauts to Mars and establishing a sustainable presence on the planet. Perseverance has also captured breathtaking visuals, from the landing sequence to images of Martian terrain. These visuals, combined with the rover's scientific discoveries, inspire awe and curiosity, symbolizing humanity's relentless pursuit of knowledge and exploration. This is a major milestone in the history of aerospace. One of the highlights is the Van Zyl overlook image taken in April 2021, which captures an amazing panoramic view from one of Perseverance's primary observation points. After a long journey, the rover took this shot, showcasing the wide, rolling Martian landscape. Additionally, the video and audio of Ingenuity's fourth flight, which took place on April 30, 2021, provide both visual and sound documentation of the event. Later, during its 11th flight in August 2021, Ingenuity also captured Perseverance from above, offering a unique aerial view of the rover. In September 2021, another image from Ingenuity featured the Rochette Formation, a geological feature that caught the attention of the rover. On April 19, 2021, Ingenuity even recorded the intra-descent landing debris, showing remnants of the rover's landing sequence, such as the parachute and back shell. One of the most immersive images released by NASA is a 360-degree panoramic view from Perseverance's landing site, stitching together a complete image of Mars as if you were standing right beside the rover. The latest images, released by NASA, show captivating transits from Mars, including one on January 19, 2024, where the Moon Deimos passes in front of the Sun. Similarly, images from February 8, 2024, capture the Moon Phobos crossing the Martian sky, and in October 2023, an image even captures Mercury's transit from Mars. Mars is being observed like never before, but why does all of this matter? Are a few pictures really that important? Let's dive into that. Mars has long captured human imagination as a destination for exploration and even potential colonization. The planet's mystery has sparked ambitious missions and futuristic ideas. While we're still in the early stages of exploring Mars, the advancements in technology, international collaboration, and human ambition hint that humans may one day live on Mars. This journey is not only about exploring another planet, it's also about pushing forward science, technology, and human determination. The future of Mars exploration and colonization holds great potential, but there are many obstacles to overcome. In recent decades, the evolution of our ability to explore distant planets has been remarkable. Robotic missions like NASA's Perseverance rover, the Ingenuity helicopter, and the Mars Sample Return mission have made huge strides in robotics, AI, and remote sensing. These advancements are just the beginning, and in the future, even more breakthroughs will aid in the exploration and eventual colonization of Mars. The development of efficient space travel is also a crucial step. Spacecraft like SpaceX's Starship, designed to carry large numbers of people and cargo to Mars, are pushing the boundaries of what's possible. These spacecraft will cut down on travel times and costs, making it more feasible to send humans to Mars regularly. Reusability, as shown by SpaceX's Falcon rockets, is a key factor in making long-term Mars missions sustainable. Eventually, spacecraft that can produce fuel on Mars, like by converting carbon dioxide into oxygen, will reduce the need for Earth-based resources and cut costs. Autonomous robots will also play a key role in Mars colonization. These machines will help with preparing the planet for human settlers, performing essential tasks like building habitats, extracting resources, and setting up systems for power and life support. AI will help robots and humans analyze data and make decisions in real time, improving safety and efficiency on Mars. One of the biggest challenges of colonizing Mars will be creating a livable environment. Mars has a very thin atmosphere, extreme cold, and almost no liquid water on its surface, making it a hostile place for human life. However, engineers and scientists are developing ways to overcome these difficulties. Mars' atmosphere is only about 1% of Earth's, and the planet is constantly bombarded by harmful radiation. To protect future settlers from this, habitats may need to be built underground or inside artificial domes. These structures would shield inhabitants from the dangerous radiation. Advances in technology may also help create self-sustaining life support systems, which would generate breathable air, provide safe drinking water, and manage waste. One potential method for creating a breathable atmosphere is by using in-situ resource utilization, ISRU. This process would allow astronauts to extract water from the Martian soil and convert carbon dioxide into oxygen. Technology like the Mars Oxygen ISRU experiment, MOXIE, which already extracts oxygen from the Martian atmosphere, is a step in this direction. Ensuring a reliable supply of oxygen will be critical for both the health of astronauts and the success of a Mars colony. Another major challenge is securing a reliable food source. Growing food on Mars has been tested in various experiments, including NASA's plant growth studies. By building greenhouses and using advanced hydroponic systems, future settlers could grow food on the planet. While Martian soil is not suitable for agriculture, it can be treated to make it more hospitable. Additionally, closed-loop ecosystems could recycle waste into nutrients, providing a sustainable food source for settlers. A constant, reliable power supply will also be essential. While solar power has been used successfully by rovers on Mars, it's not as efficient as it is on Earth due to Mars' distance from the Sun and frequent dust storms. As a result, nuclear power may become the preferred long-term solution, providing a stable energy source for the colony. Once a base is established, exploring the Martian surface will be the next major task. Developing transportation systems will be key for easy travel across the planet. Rovers like Perseverance are just the start. In the future, larger, more versatile rovers could carry both humans and cargo over greater distances. These vehicles will need life support systems to ensure astronauts can travel far from their base without worrying about running out of supplies. Additionally, spacecraft that can land, take off, and operate on Mars will be essential for exploring the planet and for transport between Mars and Earth. Living on Mars will present significant challenges to human health, both physically and mentally. Space radiation, muscle atrophy, bone density loss, and other health issues must be addressed before humans can live there long term. Advances in medical technology, such as telemedicine, robotic surgery, and 3D printing of organs, could help ensure astronauts have access to the necessary healthcare. The psychological aspect of living on Mars is just as important. With communication delays of up to 22 minutes one way, maintaining contact with Earth will be difficult. Support systems for mental health will be vital, including virtual reality experiences, communication with loved ones, and activities that simulate Earth-like environments. Building a strong sense of community among settlers will also be important for maintaining morale. The future of Mars exploration and colonization will require cooperation among various international space agencies, private companies, and research institutions. Organizations like NASA, the European Space Agency, and Roscosmos will likely work together to develop the infrastructure needed for human exploration. Private companies like SpaceX and Blue Origin are also contributing significantly to space exploration, particularly with their reusable rockets and spacecraft, making space travel more affordable and opening up possibilities for commercial activities on Mars. Today, all we have are images and videos, but tomorrow, Mars could be our second home. As we continue making progress, we can marvel at these stunning visuals and dream about the day we might actually set foot on the red planet. The future of Mars exploration and colonization is bright, though full of challenges. One day, humans may walk on Mars, establish colonies, and unlock its many secrets. While there's still much to be done, the rapid advancement of technology and human determination make it seem more and more likely that a new era of space exploration is on the horizon. Mars presents the opportunity to expand humanity's reach beyond Earth and create a sustainable colony that could serve as a model for other planets in the future. Thanks for watching. If you enjoyed this video, consider liking, commenting, and subscribing to stay updated on our future uploads. Don't miss the video you see on your screen now, it's truly unbelievable.